This video is to show you how to use the method of substitution to solve a system of equations. Again, we've previously solved graphically, and there's a longer video made about why we use substitution. This is more of a how-to video. Substitution is a really good method for how to solve equations or solve systems of equations, to find that one coordinate where both equations cross, right? Or both lines, if we graph them, would cross. Number one, we need to solve one of the equations for one of the variables. So looking at our equations that we've been given here, we've got a negative x, which would be easy enough to solve for, but I would argue that both of the y values, because they're already positive values in our equation, would probably be easy to get all by themselves. So the first thing that I'm going to do is I'm going to go ahead and grab that second equation, notice, and I'm going to subtract 2x. I'm going to subtract that 2x from the left, subtracting 2x from the right, thus leaving us with, again, when we get rid of this 2x here and this 2x there, leaving us with a y equal to negative 2 minus 2x. Again, not like terms, so we can't put those together, but again, easy enough anyways to get those two things by themselves. So that second equation is just rewritten here for us. Y equals negative 2 minus 2x, the exact same equation as that second equation there. Then comes the big move. Step number 2, the major step that we use for substitution here. Substitute the equation from step 1, right? Substitute from step 1 into the other equation and solve for the other variable. So again, we're going to take that y value out of the first equation, right? We're going to go up here and say, okay, well, if y here is equal to negative 2 minus 2x, then why not insert it for the y in that first equation? Again, if we're going to find the point where both equations are true, then those have to be the same y values from the second equation and the first equation, the same number, they're equal to each other. So we're going to take that negative 2 minus 2x, and we're going to insert it. Notice that's that top equation, negative x plus y. Well, y was equal to negative 2 minus 2x. And now we're still equal to 1, right, from that first equation. After that, it's basically just an equation with some x's in it. So we're going to go ahead and, if there were a number in front of the parentheses, we would distribute. Since there's not, we can just get rid of those parentheses. I'm going to combine my like terms. Negative x minus 2x would be a negative 3x. I've got a negative 2 right here, so there's still a minus 2, and we're equal to 1. If we add 2 to the right side, and then we divide by that negative 3 to get rid of it on the left side there, all right, divide by negative 3 in that last step, we're going to end up with x equals negative 1. Again, if it helps, write that first equation out and just walk yourself through. Again, get rid of the parentheses, combine your like terms, make negative 3x, and then we just have to solve the equation. So I added 2 from the left over to the right, and then I divided, since we were multiplying, divided by negative 3. That gives us half of our answer. The next step is to substitute, take that negative x then, or take that negative 1, I should say, that x value, and let's plug it back into one of our original equations. Well, now this nice equation here, that second equation's been rewritten. So if I plug negative 1 right back in here, you'll notice we have y equals negative 2 minus 2 times x, right? We're just plugging that in for that negative 1 right here, which makes for negative 2, negative would be plus 2, right? Negative 2 times negative 1 would have been positive 2. So negative 2 plus 2 would be 0. And our answer then is negative 1, 0, the solution to our system. The last thing you'd want to do is go ahead and plug those in then to your original equations. So notice that's just equation 1 written over here at the left. We get 1 equals 1. And if I plug negative 1, 0, again in for x and y in the second equation, right? Just plugging that one in down here. Negative 1, 0 plugged in there. I get negative 2 equals negative 2. And notice it checks in both equations. Right? So we know that this solution works in both equations. Now you can either write the two numbers separately like we have here in the blue, or wouldn't be a bad idea to write it as a coordinate and identify that's the solution to my system, negative 1, 0. Again, let's do that a little bit quicker here with this set of equations. So the first thing I notice is I've got an easy y to solve for in that first equation. So I'm going to take my equation and I'm going to say, let's subtract 6x from both sides. So 6x plus y is equal to 37. But again, I'm going to subtract my 6x on both sides here. And I'll get the equation y equals negative 6x plus a positive 37. Let's take that y value then, and let's insert it, right, for y in the second equation. Make sure you insert it into the other equation. You don't want to put the equation back into itself. We'll talk about that later in the chapter. 4x plus 2 times y then, well, y, remember, was negative 6x plus 37, that's what we just figured out, is still equal to 18. So it's my second equation, only removing the y and inserting what I know y is equal to. Then we do a little distributing. 4x, I'm going to distribute that 2 into the parentheses. So 2 times negative 6 would be a negative 12x. 2 times 37 would be 74. We're going to subtract 74 on both sides. So 4x minus 12x would have been a negative 8x, right? We can combine like terms there. But again, I'm getting rid of the 74 by subtracting it over to the other side. 18 minus 74 would be a negative 56. And now, since we're multiplying by negative 8, let's divide by negative 8. And x equals 7. Take that x value, we're going to plug it back in, right, to our other equation. Well, remember, this was the first equation up here, right? 6x plus y equals 37. Could be rewritten as y equals negative 6 times x, which we now believe to be 7, plus 37. So y equals negative 42 plus 37, or y equals negative 5. Again, I would highly recommend take that coordinate then, right? 7, negative 5. You could plug it back into both of the original equations, check your answer, but make sure that it makes both equations true. Right? It should make both equations true. Finally, where can we really use this substitution idea? Well, here's just a quick example for you of a real-world example, kind of an old one. An office supply company sells 2 types of fax machines, a way to send old-fashioned paper documents, right, before we could scan them in and email them to each other. An office supply company sells 2 types of fax machines. They charge $150 for the XP 1050 and $225 for the Laser Y30. If a company sells 22 fax machines for a total of $3,900, how many of each type were sold? Well, if we're finding how many of each type, let's define a couple variables. Let's call X the number of XP 1050s, and we'll call Y the number of Laser Y30s. Let's define 2 equations then. Well, the first equation is just to say, well, X plus Y, right, all the fax machines put together should be 22 total fax machines. Then $150 times X would be the amount of money we spent on XP 150s, right? Or 1050s. Plus $225 per Laser Y30, and all the money put together was $3,900, right? Well, in that case, again, we've got 2 equations. That first equation is fairly easy to solve for a variable. You can pick either X or Y. I'm actually going to go ahead and leave X all by itself. I'm going to subtract Y over to the right side. So hopefully you believe me that X plus Y equals 22. Well, then X equals 22 essentially minus Y, right? Subtract that Y over to the right side. Let's insert that into this equation. So we're going to say 150 times X, which we now know is equal to negative Y, plus 22. Plus, we've got 225y. Remember, we're rewriting this whole equation here. All we did was took out the x and plugged in what it was equal to, right? So again, the rest of the equation still needs to be rewritten out up here. Let's do a little distributing. Negative 150 times y here. And 150 times 22, I might have to think that one out there. 2 times it's going to be 300. I believe that's 3,300 Okay, you can always check me on the calculator there. Still got 225y equals 3,900. I'm going to go ahead and subtract my 3,300 and at the same time add my like terms here. Negative 150 plus 225 is going to be 75y. And if I subtract 3,300 from both sides, that gives me a positive 600. Divide by 75, and y equals, well, I believe that comes out to a simple 8. Again, you could always double check me on that one, but I'm pretty confident y equals 8. Take that y value, plug it back in. Again, I would go ahead and grab this equation right here. X, remember, equals negative y plus 22. So x should be equal to 16. Oops, sorry, not 16, 14. And I believe our final answer then should be that they sold 14 XP 1050s and 8 laser Y30s. I hope that helps you. Again, setting up a couple of equations for a system. Solving by substitution is just a great way to solve that system. Remember, find one variable, plug it back in, find the other, and then don't forget what your labels were. That's where it's nice to define those variables up top. X is the 10P 150s, and Y is the laser Y30s here. If you have any questions, talk to your teacher. Otherwise, have a great day.